All right, guys, we are going to learn about something called completing the square, which is something that I know you guys learned in Algebra 1, but I think you were probably very resistant to it then, and you are going to pretend like this is the first time that you've ever seen this, but I promise you that you haven't. We are going to walk through it kind of slowly. First thing we're going to learn about is something called the square root property, and so we need to review something called a perfect square trinomial. So I'm just going to make a little note. Perfect square trinomial, and it's a pattern that we learned about in 4.3 when we were doing all the factoring. It was one of the first things we learned about was this perfect square trinomial pattern, I guess, of factoring. It's the perfect square trinomial. What you're looking for is that the first thing is a perfect square. So like with this one right here, the x squared is a perfect square, and then the last thing is a perfect square. And then the middle term, and this part is a little bit tricky, the middle term is 2, let me see if I can explain this better. So like this one right here, x squared is a perfect square, 36 is a perfect square. If you take their square roots, you get x and you get 6. This middle term is always going to be x times 6 times either plus or minus 2. That's the perfect square trinomial. So let's write this down. The perfect square trinomial pattern is like an x squared plus 2 times b times x, and then plus something called b squared. Okay, and what that factors down to is x plus b quantity squared. So we'll work on this one really quickly. So x squared minus 12x plus 36. So the first term is a perfect square, the second term is a perfect square. Square root of x squared is x, square root of 36 is 6, x times 6 is 6x. If I multiply that by a negative 2, I get this middle term right here. So what I do is I first want to factor down this left-hand side, and it's having you solve each equation using the square root property. This is kind of a unique situation because before, when we were solving, I told you guys that you're supposed to get everything in standard form, which means everything on one side and just 0 on the other side. We actually don't want to do that here, and that's because the left-hand side is one of those perfect square trinomials. And so when I factor this down, what I have is I get x minus 6 times x minus 6 equals 25. And so this, if you kind of refoil this out, x times x gives you the x squared. X times negative 6 gives you a negative 6x. Negative 6 times x gives you another negative 6x, and that's the negative 12x in the middle. And then negative 6 times negative 6 gives you 36. So when you're checking these two numbers right here, the negative 6 and the negative 6, they multiply to 36 and they add to negative 12. So the pattern that we're looking at here is the square root of this number is half of this number. I probably could have said that earlier. I just came up with a nice, concise way to say that. The square root of this number is half of this number. And so we write this, instead of writing x minus 6 times x minus 6, we can write it as x minus 6 squared. Because you know that's what it means when anything multiplies by itself, is it's that thing squared. So we write it like this first, and this is where we use what we call the square root property. And you guys know how to take square roots, and so what we do is we take the square root of both sides. We're used to other algebra things where like you add the same thing to both sides, or you subtract the same thing from both sides, or something like that. What we're going to do here is square root both sides. Okay, and now here's the thing that everybody forgets about. On the left-hand side, we have something squared. If we square something and then square root it, those two things cancel each other out. It's kind of like adding and then subtracting the same thing, or multiplying and then dividing by the same thing. They cancel each other out, so all I have is the x minus 6. Here's the part that everybody's going to forget. The square root of 25 could be positive 5, but it could also be negative 5. And so what we're going to do is we're going to write plus or minus 5. That is the part that you need to try your hardest to remember, okay? And then what we're going to do is we're going to add the 6 to both sides. Okay, so let's move this over here. X equals, so these 6's will cancel, and we have a positive 6 plus or minus 5. Don't leave it like that because we know we can simplify that up. So x equals 6 plus 5, which is 11, or x equals 6 minus 5, which is 1. So those are our two answers, and you can always check them in the original equation. Say I plug in the 1, for instance. 1 squared is 1, minus 12 is negative 11, plus 36 gives us 25. We could also check the 11. 11 squared is 121, minus 12 times 11 is 132, and then plus 36 will in fact give us 25. You can always check these on your calculators by storing 11 as x and then plugging in the original equation, then you'll see that you get a true statement. All right, let's look at the next one. The next one is also a perfect square trinomial on the left. X squared is a perfect square, 64 is a perfect square, and the square root of 64 is half of this number. Remember, the square root of this number is half of this number. Don't let the negative throw you off, because the square root of 64, remember, could be positive or negative 8. Half of this number is a negative 8. So here's the pattern. See here how I have an x minus 6 quantity squared? I can go right to that point right here, except it'll be x minus 8. So notice the pattern here is that half of this number, which is also the square root of this number, is what goes right here, negative 6. So half of this number is a negative 8, which is also one of the square roots of this number, and that's what goes right here, x minus 8 quantity squared. If for some reason you ever don't believe me, you can do a little side work right here. X minus 8 times x minus 8, you can FOIL it out. X times x gives you x squared. X times negative 8 gives you a negative 8x. Negative 8 times x gives you a negative 8x, and negative 8 times negative 8 is a positive 64. So when you combine up those middle terms, this is exactly what you get. So it's x minus 8 quantity squared, and then we leave the 49 right here. Okay, so that was our first step. We kind of missed a step right here. Not missed a step, intentionally skipped a step, I should say, because we figured out that there's a pattern, and so we can just jump right there for this problem. So then we do the same thing for the next step, is we are going to square root both sides. And so on the left-hand side, what happens is I've got something that I squared, and then I square rooted it. Those two things undo each other. If I square root and then square something, I'm just where I started with like the x minus 8. Say, for instance, that I took 4 and I squared it, that would give me 16, and then if I square rooted it, I'd be right back at 4. And so that's the logic that we're using right here. Equals, again, here's the part that you're going to forget, the square root of 49 could be positive 7, but could also be negative 7. So we do plus or minus. Every time we take the square root of a number when we're doing something like this, we do plus or minus. Then we add the 8 to both sides. So we have x on the left equals 8 plus or minus 7, and just like the one up above, you don't ever want to just leave it like that. X could be 8 plus 7, which is 15, or x could be 8 minus 7, which is 1. And same thing as we could do up above, you could plug those into your calculator, check out your answer, see how it goes. All right. Next, we've got 2 more of these. Now, in case you're wondering why these fall into a different category, I will explain it while we're going, because these are also square root properties, and so in case you're wondering why this is in a different section, you will see in just a moment. So start on the left-hand side. We've got x squared plus 8x plus 16. You got to always check it really quickly to see if it falls within that pattern. 16 is a perfect square. The square root is 4, and 4 is half of 8. So you know it does fit that pattern. And half of 8 is a positive 4. Positive 4 is one of the square roots of 16. So we always write half of the 8 inside of the square root there. Again, and I will do this just one more time, in case you are, hesitant or whatever, if that pattern actually works, x plus 4 squared, remember, is x plus 4 times x plus 4, and then I can FOIL. So x times x gives me x squared. X times 4 gives me 4x. 4 times x gives me 4x. And 4 times 4 gives me 16. So if you combine up these middle terms right here, you do in fact get the 8. So I promise that is the way that you factor this left-hand side down. And then the right-hand side equals 20. Okay, so it looks like you're starting off pretty much in the same place that we were at last time. Here's why this problem is different. I'm going to do the same next step. I'm going to take the square root of the left. I'm going to take the square root of the right. When I take the square root of the left, the square root cancels out with the squared, and so I just have the x plus 4 left. But here's where things are different. The square root of 20, not a perfect square. On the previous page, we had the square root of 25. We had the square root of 49. Those are both perfect squares. This one is not. It's fine. We can still do this the same way. What we write is we write the square root of 20. So first of all, when I'm taking the square root of a number, it's always, always, always going to be plus or minus. And then if you guys remember in Algebra 1, maybe even geometry, simplifying up square roots, the square root of 20 does not come out evenly, but I can simplify the 20 up a little bit. 20 is 4 times 5, and 4 is a perfect square. So I can take out the square root of 4, which is 2, and I leave the 5 underneath the square root. And remember, of course, it's plus or minus. If you guys remember that little unit on simplifying radicals. So the square root of 20 is not even, but 4 is a factor of 20, and that is a perfect square. So I can simplify this up a little bit. So I can pull a 2 out of the square root, because again, the square root of 4 comes out evenly, but there's still a 5 under the square root, and that's not even. Last thing I do is subtract 4 from both sides. So it cancels here. I write x equals, I have a negative 4 that I just moved over to the right-hand side here, plus or minus 2 root 5. Now for these ones, since it's this gross square root term, it's something irrational. Remember, anything square root that you can't simplify is irrational. I actually just leave it just like this. Negative 4 plus or minus 2 root 5. Now this isn't something that you'd be able to check in your head for sure. You could do a check in your calculator, and we can go over this in class. So you just write it like this, nice and compact. That's 2 irrational numbers, which is totally fine. It's just not something that we're used to, but we'll get there. Okay, next one, same thing. X squared minus 6x plus 9. So the left-hand side is already one of those perfect square trinomials. 9 is a perfect square. Its square root could be positive or negative 3, and half of negative 6 is negative 3, so we know it fits the pattern. So inside the parentheses, we write half of the negative 6, which is negative 3. I'm not going to do this again because I've already done it twice, but if you don't believe me, you can always multiply out the x minus 3 times x minus 3. And then on the right-hand side, we have a 32. So starts off, again, very similarly to the ones we were doing on the previous page, but the right-hand side, again, is not a perfect square. So we're just going to do the same thing that we did up above. Okay, so the square root of x minus 3 squared leaves me with just an x minus 3, because just like the other 3 problems, the square root and the square cancel each other out. And then the square root of 32. Let's do a little side work over here. Again, 32 is not a perfect square, but just like we did up here, we can kind of break it down into different factors. So the biggest factor of 32 that is a perfect square is 16. So the square root of 16 comes out evenly. It comes out to be either positive or negative 4, and then I can't do anything with the root 2. So I leave it just like that. Plus or minus, because I always have a plus or minus when I take the square root of a number. And then I have to leave the root 2 underneath. Again, a little bit of practice with simplifying radicals if that stuff isn't immediately familiar to you. Last step is I'm going to add the 3 to both sides. This one will cancel, and I'll get x equals the 3 that I put onto the right-hand side right here, and then plus or minus 4 times the square root of 2. Now the ones on the previous page, we simplified them down because they were just whole numbers. These ones are not, so we leave them just like that. And this is technically 2 different answers. We have 3 plus 4 root 2. We have 3 minus 4 root 2. You just might as well leave them in a compact answer like that. And then another note is you always want to leave it like this. You don't ever want to plug it into your calculator and get a decimal. We want to write an exact answer whenever we can. And leaving it as a square root is called an exact answer. Okay, let's do a little bit more here. Completing the square. All quadratic equations can be solved using the square root property, but the thing is you have to kind of manipulate one side of the equation until it looks like a perfect square trinomial. So we've talked now 4 times about how the left-hand side works when we've got this perfect square trinomial. The pattern is that this has to be a perfect square, and the square root of this number is half of this number. Okay, so we'll go through that pattern again. So it says consider this number right here. X squared plus 16x equals 9. What value is needed for the perfect square? So we need something right here, like x squared plus 16x plus something equals 9. Because that's the pattern that we had up above, like there's supposed to be something here. And so again, the pattern tells us that the square root of this number is half of this number. Okay, so here's what I do. I start off by finding half of this number. Okay, so I take half of this number, 16 divided by 2, that gives me 8. So half of this number is 8, and again, half of this number is the square root of this number. So whatever this number is, its square root is 8. So the next thing I do is I take the 8 and I square it, and that gives me 64. So what I put right here is a 64. All right, now last thing. You can't just add 64 to the left. That totally makes our equation unbalanced. We've just changed things completely. But what you can do is you can add the 64 to the other side as well. All right, so we add 64 to the right-hand side. All right, and then what we do is we're going to simplify up that left-hand side, and then we can start simplifying everything down. So on the right-hand side, we've got 9 plus 64, that is a 73. And then on the left-hand side, we just turned it into one of those perfect square trinomials, so we can write it as x, and then we write half of 16, which is 8 squared. So x plus 8 quantities squared equals 73, and now it looks just like the ones up above with just a little bit of manipulation. Okay, so we're going to write down the steps. We're going to do a couple of these, and we're going to save some more of it for the next lesson tomorrow. All right, so completing the square. To complete the square for any quadratic expression, here are the steps that you follow. So first you find 1/2. One-half of b. And remember, b is whatever the coefficient on x. So let's actually write this. So that's the first thing we did here. We were like, well, we know the pattern says that this number is going to be half of this number, so let's figure out what that is. Now, of course, finding half of 16 is not all that complicated, but eventually we'll have like odd numbers or fractions or more complicated things. Starting with the easy stuff today, though. So first we find half of b, and then you square that number. So that's the next thing we did up here, because the pattern tells us that the square root of this number is half of this number. So if I can find half of this number, I just square it to figure out what that number should be. And that's the pattern. And I'm going to go through right now and show you that all of them fit the pattern. If I take half of this, I get 8. If I square it, I get 64. If I take half of this, I get -3. If I square it, I get 9. Half of this, I get 4. If I square it, I get 16. 2 more. Half of this is -6. Square it, and I get 36. Half of this is -8. If I square it, I get 64. One other thing to point out that will always be true, these numbers, the c in ax squared plus bx plus c, is always going to be positive. Here, here, here. The reason is that's because you're taking half of something and then you're squaring it. Every time you square something, it comes out positive, no matter how it started. Okay? And then last, add the result. So whatever you get from step 2, add the result to like the x squared plus bx that you started off with. And then from there, it becomes just like one of these problems that we had up above, and then you can solve it using the square root property. All right, so let's do just the rest of this page. So first of all, find the value of c that makes x squared minus 14x plus c a perfect square. Okay, so let's follow these steps right here. So we have our x squared plus bx right here. We're trying to find the plus c that makes it a perfect square trinomial to fit all of the patterns that we had up above. All right, so find half of b. So that's our first step. We take -14, which is b, and we cut it in half, and we do that by dividing by 2. So that gives us a -7. So that's step 1 right here. Next step, square that number. So when we take -7 and square it, remember you're multiplying a -7 by a -7, so you end up with a positive 49. Okay, and then add the result to x squared plus bx. So x squared minus 14x plus 49. And that is now a perfect square trinomial. Half of this number is -7. I square it to get 49. The pattern that we were talking about before is that the square root of this number is half of this number. So now I can write it as a perfect square, and that is x and then half of the -14 squared. Okay, let's do just one of these all the way out. Okay, so solve each equation by completing the square. So let's talk about this first. The left-hand side, I'm used to it just being the x squared minus 10x, kind of like this one up here. So the very first thing you do, if we're looking at this one, we're like, no, this is not a perfect square pattern. -10, 24. 24 isn't even a perfect square. So we're trying to figure out how on earth we can make this work in the pattern that we just started. the 24 is really just kind of messing things up. So for completing the square and only completing the square, our first step is actually to move the constant to the other side. We're not used to that. It might feel a little bit tricky at first because I've been telling you the last couple sections to get everything on the left. But for completing the square, that's what we start with. So we have x squared minus 10x equals a negative 24. I'm leaving a space here because we need to finish off the perfect square trinomial, just like we did up here. Okay, so follow our steps. So find half of b. Okay, half of b is a negative 5. Next step, square that number. Okay, and add the result to x squared plus bx. So I add 25 to the left. Think algebra, think what you're allowed to do and what you're not allowed to do. If you're going to do something to the left-hand side, you have to do that to the right-hand side. Basic rules of algebra. So that's where I'm at so far. Next step in my square root property is I'm going to take the left-hand side and I'm going to write it as a perfect square. Half of the negative 10 is negative 5, so I write this as x minus 5 squared. The right-hand side, of course, simplify it up and I just get 1. And then I follow the same steps that I was following at the beginning, where it was already set up like this. I take the square root of both sides. The square root of x minus 5 squared comes out to be just the x minus 5. The square root and the squared cancel each other out. And then on the right-hand side, the square root of 1 could be positive or negative 1. Do not forget about your plus or minus. Very easy to forget, very important not to forget it. And then to get our answers, we're going to add 5 to both sides. So x equals, this cancels, the 5 that I just moved over, plus or minus 1. So x could be 5 plus 1, which is 6, or x could be 5 minus 1, which is 4. Okay, so you could plug these right back into this equation, test it out, see what you get for your answers, and I promise you that the 6 and the 4 will work. Okay, so we're going to finish up the completing the square stuff on the next lesson.